Okay, tell whether the following pairs of molecules or compounds are identical, constitutional isomers, stereoisomers, or unrelated. So in A, we have cis-1,3-dibromocyclohexane. So we don't really need to draw a chair cyclohexane to figure out whether these are stereoisomers or constitutional isomers or identical. We can use the sort of hexagonal form of cyclohexane to get at this answer. So 1, 3, so we have 1, 3, and let's just say they're cis. They're cis, it says in the problem here, so we'll put them on the same side, versus trans 1, 4. So this is 1 and this is 4. And we can number the carbons just to make sure, 1, 2, 3, or 1, 2, 3, 4. So since we have the methyl groups at 1 and 3 in this structure and the methyl groups at 1 and 4 in this structure, these are constitutional isomers. Constitutional isomers. Because they differ in the way the atoms are connected. And it's not just how they're presenting in space, but since the methyls are at 1, 3 here and 1, 4 there, these are essentially different molecules, different constitutional isomers. So 2,3-dimethyl cyclohexane and 2,3,3 dimethyl hexane, not cyclohexane. 2,3-dimethyl hexane. So let's draw hexane and we'll count from this side. So 2,3-dimethyl hexane versus a pentane here, 2,3,3 trimethyl Well, are these even isomers at all? Let's count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, C8. And since these are simple alkanes with no rings or double bonds, we know this has to follow the 2n plus 2 rule. So C8H, 16 plus 2 is 18. And let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8. Again, C8H18. And so these, since they have the same molecular formula but essentially different skeletal structures, these are also constitutional isomers. And in C, we have 2 cyclopentane rings, and the chlorines are on the same side, so they're cis. And the way these are drawn, the chlorines look like they're on these carbons here and on these carbons here. So you would think that maybe those are stereoisomers or constitutional isomers, but really they're identical, and we can just draw any 1,3-cyclohexapentane. So let me draw that a little better here. So cyclopentane, and we have a chlorine. We'll just draw it this way. So Cl, 1 and 3. And if you look at this one up here, 1, 2, 3. If you number starting with this chlorine, 1, 2, 3 on this one and on the one on the right, both of these have a relationship of 1 and 3. The chlorines are on the 1 and 3 carbon. And here they're on the 1 and 3 carbon. You're just numbering the molecule differently. So we can draw the structure on the right in the same way. They're on the same side, the chlorines. And these are identical. Different color, but identical compounds.